When you glance at the rested surface of Mars through the pictures, you can easily see that Mars is a quiet place with a flat, dusty landscape that seems to stretch in all directions. Nothing but scattered rocks and the gentle wind to dispel lonely, suffocating loneliness. But stay a little longer on this road, and you'll soon see a towering wall of dust and sand at the horizon. At first, you might think this dust storm is similar to the ones we see on Earth, not knowing that this storm is about to grow so large that its thick layer of dust will swallow not just an area, not just a continent, but the entire planet. Its suffocating dust will obscure the light for weeks, even months, and is a major challenge to the continuity of any human technology there. If we want to settle our red planet, that will be an obstacle we must overcome. Mars did not always face planet-scale dust storms. Although Mars is now a barren, arid planet, it once had a thick atmosphere warm enough to support the existence of flowing water. However, over its billions of years of existence, Mars is depleted, and its atmosphere has been blown away until its atmospheric volume was less than one of what we have here on Earth. However, those dust storms did not just start happening because Mars became arid. Although researchers do not understand everything about the origin of such storms, they believe the most important factor is the temperature of Mars, with less atmosphere, despite the planet's high lateral levels. Mars is much worse at retaining heat when the surface begins to cool. That's when, if you stand on the planet's equator at the warmest time of the day, your feet might feel 23 degrees, while above your head it will be 0 degrees. This means that between day and night, Mars has a huge temperature swing, currently ranging from a high of about 27 degrees to a freezing 133 degrees at night. The temperature difference can form winds that can lead to different weather systems across a planet. However, the erratic weather on Mars is no longer driven by rainwater cycles, but by a cycle of dust. Dust plays a surprisingly important role on Mars, and without it, the planetary storms that stretch across it might never form. The atmosphere may be too thin to collect and transport heat, but Martian dust is now another story. It all starts when Martian dust gets into the air. There are several mechanisms to help this happen, one of which is dust devils, which Mars goes through thousands of times a year, usually in spring and summer on Mars. The warm rays from the sun heat the ground, causing the air next to it to rise and the cooler air from the atmosphere to be sucked down to fill a vacuum. These contrasting winds create spirals of rising air. Some are small, but there are also giant ones that are hundreds of meters wide and 8.5 km high, regardless of their size. As they move across the dusty deserts of Mars, they suck in dust and throw it into the atmosphere, creating a cloud of haze in the sky slightly dark after they appear. This process is believed to contribute to the formation of a continuous background of dust haze in the Martian atmosphere. Although this is the fastest way dust gets into the atmosphere, it is not the most common. More common is the simple effect of wind moving across the dusty surface of Mars, and a process called saltation, where Martian dust surprisingly kicks up into the air. The smaller particles have a lot of evasion due to electrostatic forces, meaning they need a certain momentum to be blown away. Oddly, larger dust particles are actually easier for the wind to carry because they are less sticky. So these larger particles will be picked up by gusts of wind moved a short distance. But because they are eventually too heavy, the wind cannot blow them out. They fall down. And the force of these small impacts is enough to overcome adhesion and carry lighter dust into the air once they get airborne. The low gravity of Mars makes it very easy for dust to remain in the planet's atmosphere for a very long time, weeks or even months, which is enough to start driving the formation of storms. Because unlike the thin air around them, the dust particles actually absorb heat from the sun very well. The sun warms the dust in the atmosphere. They act like tiny radiators, gradually releasing the accumulated heat into the surrounding air where previously the warmth had moved down to the ground below. This makes the nearby air much warmer, and the air rises. But now it starts to do so on a much larger scale than when forming dust devils before. Wind must be drawn in from all sides of the rising air mass, but this only adds fuel to the fire. More wind means more saltation, more dust flying into the atmosphere, and more opportunity for the air to warm up. Eventually, this out-of-control process will turn into a regional dust storm on a local scale. A dust storm on Mars, by nature, is not overly dangerous. The maximum wind speed reaches 97 km, which is only half the speed of a terrestrial hurricane. And even this can be misleading because the thin atmosphere means that even when it moves fast, we won't feel it as much. Unlike what you might see in some science fiction stories set on Mars, dust storms are not strong enough to push spacecraft or break satellites. However, these storms carry their own random dangers. This is bad news for any Mars rover that operates on solar energy. If a dust storm filled with static charged, slightly sticky dust suddenly blows overhead, the dust settling from such storms is enough to block sunlight from reaching the solar panels of the rover. This marks the end of many missions from Earth. However, the issue becomes even more serious when you begin to scale these storms to increasingly larger sizes. Mars does not have a perfectly round orbit annually. During the spring and summer in the southern hemisphere, this planet is closest to the Sun and generally the warmest, for reasons that scientists do not yet fully understand. At this time of the year, local dust storms begin to merge into a superstorm of enormous size, as large as a continent. Perhaps some storms happen to form and they begin to merge at close distances. Although the regularity of them seems like a coincidence, that is not a satisfying explanation. After all, these happen every year like clockwork when the temperature is warm enough. But those are just continental scale storms. Scientists to this day still do not have an explanation for planet-scale storms. They occur about once every 3 years on Mars, which seems like a short enough period for researchers to rule out the Milankovitch cycles as they origin, as those cycles typically operate over tens of thousands to hundreds of thousands of years. Perhaps there is some aspect of the dust cycle that needs to be replenished, and it takes 3 Mars years, or 5.5 Earth years, to do so. While most Martian dust storms last only a few days, the peaks of these storms can last for weeks. The impact of these storms can be profound for any human technology across the planet. Scientists can measure the availability of sunlight on Mars using a metric called optical depth, which checks how much sunlight is absorbed or reflected by pollutants in the air. Optical depth on Mars is usually around 0.5, and we need it to be ended too before rovers like Opportunity or landers like InSight can clear their solar panels. Smoke from a Earth forest fire begins to turn day into night with an optical depth of 7. The planet-scale dust storms on Mars have an optical depth between 9 and 11, showing near complete sunlight blockage. In 2018, such a storm overwhelmed the Opportunity rover by covering its solar panels, forcing it into hibernation mode, without electricity running through its heaters. The drastic temperature fluctuations between day and night caused something critical in Opportunity to break, and it never woke up. Interestingly enough, dust storms were on Spirit. In 2004, one of Spirit's solar panels was covered with a lot of Martian dust during its operation, severely reducing the rover's ability to absorb energy. At that time, a series of systems on Spirit had been temporarily suspended due to a lack of energy, threatening the survival of the mission. However, the source of a dust devil passing through the area where the rover was parked swept the dust off the panels, allowing the device to receive solar energy and resume a normal operation. In 2021, the dust devil passed over the Perseverance rover. Unfortunately, its microphone, the Supergamma, recorded for the first time the intense sound of a dust storm on Mars, giving us an authentic experience. While Perseverance didn't have to worry about energy while the dust devil swept through because it was equipped with a nuclear battery, they still cause other problems. Dust clouds thick enough to block communication to and from the planet's surface mean scientists have no choice but to wait for them to pass. But that's not all. Even satellites can be affected by these storms. The huge amount of hot dust in the air causes the entire atmosphere to expand, pushing some of the dust into the orbit of satellites. Mission Control has to borrow precious fuel to adjust their direction to ensure that the atmospheric drag doesn't pull the satellites out of the sky. If you are a human wanting to settle on Mars, you need to find ways to overcome these problems. Settlements using solar energy would not be able to survive such storms without alternative sources of energy. And humans could not survive the freezing temperatures. Losing the ability to communicate with satellites would also isolate us and make us vulnerable for weeks. People would need to have a certain level of self-sufficiency because if something happens when the storm is blowing, we won't be able to call for help. However, over time, the storms also destroy themselves. Blocking too much sunlight eventually causes the planet's surface to no longer be warm enough to create the winds that lift and carry dust into the air in the first place. Without additional dust being lifted, these storms will starve and dissipate. The silence returns to the red planet, and any surviving rovers can emerge from hibernation ready to continue their scientific work as soon as communication with Earth is re-established. As of 2023, there are 2 active rover missions on Mars: NASA's Curiosity and Perseverance. They will need to be cautious as the most recent superstorm was in 2018. And since these storms occur on average every 5.5 Earth years, the next one could potentially appear soon. For the wind will start to blow, a bit of dust will start to stir, and the cycle will begin again. A study of the mechanisms behind Mars' best storms is essential for humanity's ambition to settle on the red planet. But as of now, scientists cannot do much about this issue as there is too little data on it. All existing equipment does not operate normally in a Martian dust storm. Immerse as Mars plans. Human settlements may be up underground or in enclosed dome structures. Besides solar energy, there would be nuclear energy as a backup. The exact location where humans will live on Mars is still unknown. But for decades, designers have been studying how future societal models could function on Mars once the technology permits. The results of these studies show an environment best suited to closed structures, evenly divided between living areas, amenities, and research and engineering sectors. These designs not only consider basic survival, but also pay attention to the mental life of the inhabitants through aspects of design and a gentle environment aesthetically. However, in the end, Mars is still a planet where humans have never lived. What is called the Mars plan today may not be beatable on Mars.